Okay, let's start. Today we are having more examples about liquid ratio test and the power. The first one, under the rule hypothesis, there's a random variable x, which has a CDF F0, and under alternative, you have a CDF F1. And x is defined as 0 to 1. Okay. So we have the rule hypothesis and the alternative. F0, which is x squared, F1 is plus 3. Okay. And the first one, we want to find the LRT, so it's the liquid ratio test. Okay. The liquid ratio test is the ratio of the density. So it is equal to like this under the alternative. And this is equal to the derivative of the CDF. So it can be like this. And then we can see this is equal to 2x divided by 3x to the power 2. So it's like this. Okay. Then you can see it is a decreasing function. As s go to infinity. So that means the rejection region for the LRT is x should be larger than some constant c. And now we want to find the c alpha. Okay. So we want to define alpha equal to the probability for x greater than c. Condition on the rule. Okay. So then we know this one is equal to 1 minus f0 c. So which is 1 minus, under the rule hypothesis, the CDF is x squared. So it's equal to c squared. And we can solve the equation. We can get the c squared is equal to 1 minus alpha. So c is equal to 1 minus the square root. So we can let the c alpha equal to, okay. So now we have the liquid ratio test is we reject when x greater than this, accept when x smaller than this. Okay. Okay. And the power B, we want to find the power. Okay. We know the power is equal to the probability of reject under the alternative. So it's equal to probability of x greater than this under the alternative. So it's equal to 1 equal minus f1 this. So it's equal to 1 minus this to 2 power 3. Okay, that's the power. Okay. And then let's go to question 2. The question 2 is we have a 2 probability density, F0 and F1. And we want to show that we want to find the power where alpha equal to 0.1. It's not just the power, we want to find the largest power. So how large can the power be? So in this kind of problem, we have to apply the nearest lemma. So we have to apply lemma Pearson. The level piece lemma says the likelihood ratio test is the UMP test, the most powerful test under if the rule and authority are all simple. Okay, so you can see in this case the rule is the F0 and authority F1, so they are simple tests. So we can apply lemma Pearson. Okay. Since it's a simple test. Okay. So then the rest of the question is how to find the power on the likelihood ratio test. So the step 1, find the likelihood ratio test. So this is equal to the fx under the roof divided by the density under the alternative. So for the question that this is 1 and the denominator 2x. So this is a decrease function as x go to infinity. So the test region for the likelihood ratio test is x is greater than some constant c. Okay, then now we have to find the c alpha. So we define alpha equal to the probability of x greater than c under the rule. Okay, so this is equal to integrate from c to 1 dx, which is equal to 1 minus c. So we can see the c alpha should be 1 minus alpha. Okay, so now we have the test. We reduce. We have LRR the test for alpha, which is we reject for s greater than this, and we accept for s smaller than 1 minus alpha. Okay, then we have to find the power. The power is equal to probability of reject under the alternative. Yes. So this is equal to indicator function. So maybe I do one more step. It's greater than 1 minus alpha under the alternative, which is equal to integral from 1 minus alpha to 1, and under the density, which is 2x dx. So it's equal to x squared 1 minus alpha 1. It's 1 minus 1 minus alpha squared. Okay. And now we have to find the most powerful, the power under alpha equal to 0.1. So for alpha equal to 0.1, okay, maybe we can say the most power can be equal to 1 minus 0.9 squared, which is 1 minus 0.81 is equal to okay. Okay, so next is question 2, and this is today's discussion.